All right, so the product and quotient rules, like I said, we'll go over product rule today. Maybe what I'll do, let me just change this thing to just, well, I guess I can just leave it alone. But we'll just call it A and B. I'll change that stuff a little later. But whenever you have two functions that are multiplying each other, not just a number and a function, but like two actual functions, like an x squared times a quantity of x plus 1 or something like that. There is a way that you can actually use something called the product rule for that. Same with quotients. If you have x squared divided by x cubed plus 1 on the bottom, there's a way that you can do that using what's called a quotient rule. Okay, so something with fractions, you do it with quotient rules. Products, you will do with product rules. Okay, now you don't always have to do everything that's being multiplied together with the product rule, because sometimes you can just distribute it in and it's fine. Okay, I'll give you an example of something like that in a bit, but let me just give you the rule first here. So the product rule. So given two functions, let's say f of x and g of x, the product rule is used as follows. So the derivative, we're going to write d dx of f of x times g of x is f prime of x times g of x plus f of x times g prime of x. So the way I always tell people is you take the derivative of the first one first and the second one second. Okay, that's kind of like an easy way to remember which one's being done as a derivative. So since f of x is the first function, right? G of x is the second function. So notice how the first part, f of x, is the one that got the derivative, and on the second part of that, after the plus sign, it's g of x that got the derivative, right? So I always say take the derivative of the first one first and the second one second. Okay? And that'll kind of give you a clue as to how you do it. Now, let me give you an example for this stuff. Find the derivatives. Let's just find dy dx. I'll leave the rule right there for us. So if y is x squared times x plus 1. So notice it's two things that are being multiplied together. Now normally I would tell you never use the product rule on this, because you could literally just distribute. But let me show you what the product rule looks like, and then we'll do the distribution, and then you can see why it's better to distribute. Okay? The product rule is going to look like this. dy dx is equal to. So remember, I have two functions. Okay, I got the x squared and I got the x plus 1. Okay, I have two different functions. So first I'm going to take a derivative of the yellow one, right? The first one first. So the derivative of x squared is 2x times x plus 1. Right? Just rewrite your g of x function, your second function. You're just going to put it back in there. Plus, now rewrite your first function, which is x squared, times the derivative of x plus 1. What's the derivative of x plus 1? Just 1. So anyway, let's go ahead and put this stuff together here. 2x times x, that's 2x squared, plus 2x times 1, that's 2x, plus x squared times 1 is x squared. So this becomes 3x squared plus 2x. Okay? So that's the product rule. It's not that it's like insanely difficult to do. You just got to make sure you follow the order in which things have to be done. Because if you mess it up, then you can get wrong answers. Now, just to show you an alternative, if I would have just distributed, this would have been x cubed plus x squared, correct? And what's the derivative of x cubed? 3x squared. What's the derivative of x squared? And notice I got the same answer in way less steps. Okay? You're not supposed to use the product rule every time there's a product. You want to use the product rule when it's going to benefit you. Or maybe it's too hard, or maybe you're just too lazy to want to distribute something out. Then you use the product rule. Okay? But for the most cases, yes, you want to use the product rule. But there are some times when you're like, yeah, I could probably take less time if I just multiply things out. Okay? You make that call. Everybody's different. For some people, they're going to use the product rule all the time. And some other people are going to try to distribute everything. It doesn't matter if it's a 3 by 3 polynomial. They'll multiply everything till they get 9 terms and then just use basic power rule. And that's just what they want to do. And that's okay. It's still correct, just maybe a little messy. So let me give you another one here. Let's see. What if I give you y equal to 2x plus 1 times x squared minus 3x. Now you choose how you want to do it. If you want to do this using distribution, go ahead, or if you just want to go straight into power rule, go ahead. I'm going to show you what it looks like in power rule, but if you want to go the other way, that's okay. I'll give you a little bit of time to do it. Alright, so if you guys have tried it and you finished, then good. If you have not, keep going. I'm going to attempt this using the product rule, like I said. So according to the product rule, dy dx is going to be the derivative of 2x plus 1 is 2 times x squared minus 3x plus, now rewrite the first function, so that's 2x plus 1. The derivative of x squared minus 3x is 2x minus 3. Okay, now we'll distribute, so that's 2x squared minus 6x plus 4x squared. What do we get here? Minus 6x plus 2x, so minus 4x minus 3. So that's 6x squared minus 10x minus 3. So there's my product rule for that. Are we okay with that? And again, if you distributed everything completely, you should have gotten the same answer. Okay? So here's one where you have no choice. Let me see. We'll do f of x. Why is that doing that? F of x equal to x cosine of x. So you're multiplying a linear function times a trigonometric function. Okay, x times cosine of x. So you can't really distribute. You can't say, oh, that's cosine of x squared, because you're not allowed to multiply into the angle. Okay? So it's just x times cosine of x. So you're going to have to do f prime of x. Notice I've been using different notation, right? I used f prime right now. I used dy dx before. I use y prime for part A at one point, right? So I'm just trying to let you see different ways that you'll see this stuff. That it all means the same thing, but they should just write it in different ways. So f prime of x, well, the derivative of x is 1 cosine of x plus x times, what's the derivative of cosine of x? Negative sine x, right? Yeah, negative sine x. Now, I want to give you guys a word of caution. Notice how I'm using parentheses around that. A lot of people, sometimes they just leave it like this. So notice how it looks like it's a subtraction. Okay? Be careful. It's a very common mistake that people don't put parentheses around their answer. And now they think they're subtracting sine of x, not multiplying it. Okay? So, I get cosine of x minus x sine of x. And that's it. So I was just looking, and the quotient rule, it's next, and we only do one example. Other than that, I mean, we're pretty much done with the lesson once I'm done with the quotient rule. So I think I'm going to go with it, okay? Let's get the quotient rule done today as well. This one's a little bit more complicated. So given two functions, f of x and g of x, the quotient rule is used as follows. So d dx of f of x divided by g of x. Right now, I'll write down the actual definition. So it's f prime of x, g of x, minus f of x, g prime of x, divided by, and then on the bottom we're going to do g of x quantity squared. So whatever g of x, you're going to square it. So notice the top looks like the product rule, just that you're subtracting. And then then you got to divide by the denominator square. Now there is a requirement that g of x cannot be equal to 0, because if it is, then you're dividing by 0, and that's not good, right? So, but that is our quotient rule. So I'll give you an example for this one. So we're going to differentiate f of x equal to, let's do 2x over sine of x. Leave the rule there for you. Because after this one, I'm just going to give you 4 definitions that you have to memorize, which are the rest of the trig functions. So you should already know derivative of sine is cosine, derivative of cosine is negative sine. Now we're going to basically expect you to know what's the derivative of tangent, secant, cotangent, and cosecant. Okay? And once we write those down, the lesson's done. So here we go. F prime of x. Well, the derivative of the top, right? So this one is not first one first, second one second. This is numerator first, denominator second, okay? So the derivative of the numerator is 2 times sine of x minus 2x. The derivative of sine of x is cosine of x, and that's divided by sine squared x, right? Because sine of x squared is sine squared x. So f prime of x is 2 sine of x minus 2x cosine of x all over sine squared x. And that's it. I mean, if you can simplify something, then go ahead and do that. But in our case, I can factor out a 2. It's going to do nothing, though. I mean, I really can't do much more with the problem. I mean, I guess I could get really tricky and factor out a sine. If I factor out a sine from cosine, that actually becomes a tangent, and then we start getting really weird. So I'm not going to do that. Okay, I'm just going to leave it alone. So here you go. There's your answer. So notice it's not much different. I mean, we're not doing anything super tricky. It's just remember the pattern to it. Okay, make sure you memorize it so when you see these problems, you know how to work them. Okay. So the last thing are just more definitions for trig functions. Okay, or more derivatives, and then we're done. And you know what? I'm just going to write all 6 of them. Instead of the 4, I'm going to write the sine and cosine ones again just to keep them there for you guys. So we have d dx of sine of x is cosine of x. Now, I write them like this on purpose, okay? Don't think I'm doing this just to save space. I'm doing this on purpose, side by side, okay? d dx of cosine of x is negative sine of x. d dx of tangent of x is secant squared x. d dx of cotangent of x is negative cosecant squared x. d dx of secant of x is secant x tangent x. And d dx of cosecant of x is negative cosecant of x cotangent of x. Like I told you guys, I do this on purpose, the way I write them out. Can you see why? The right side's what? Negative, and the left side's all positive. Notice how all the cos are negative. Derivative of cosine, cosecant, cotangent, they're all negative. Right? All the cos are negative, and it's a lot easier to see them like this when I separate them than if I were just to write them in order. Then you'd see them kind of like flip-flopping back and forth, right? It's so much easier to be able to see them side by side. So if it starts with the co and you're taking a derivative of it, it better be negative. Okay? If it doesn't have a co on it, it better be positive. Okay? So I'm going to stop there. I'll give you guys your homework in a bit. I mean, you guys can work on it over the weekend. Let me know how it goes.